And continuing with the previous videos, let's see how we can better provision this code so that we will be able to introduce many more birds in the future without having to repeat this fly method. So first off, let's take off this fly method here. And as expected, we will have the problem in the program file because this fly method won't be found. So let's see how we can fix it. Let's introduce one more class called bird, thereby modeling a real hierarchy wherein all birds inherit from animal. And we'll also have a constructor which is basically accepting the name of the bird, and we'll also pass that to the parent constructor. And obviously the error right now is because we are yet to provide an implementation for the climb. Now here's the deal. This bird is also an abstract concept like animal. We don't know the specific implementation of the climb unless we know the specific type. So in order to keep that way, we also have to mark public abstract class, sorry. We'll also have to mark this bird class as abstract. Thereby, we are no longer obligated to implement the climb here. Because in fact, even if we want to, we won't be able to implement the climb here because we don't know how the climb actually looks unless we know the specific type. So a class should either implement all the abstract methods of the parent class which it is inheriting, or should itself be abstract. So that's what the rule goes, and the rule is made because of basically what we are trying to model. So if we do that, and also if you see, we need to now go back. We did this so that we can accommodate the fly here. And the moment I save this, the error still persists because obviously my main program is not aware that parrot is also a bird. So what I can do right now is just make it bird. So this is multi-level inheritance. So basically I have the animal class, which is inherited by the bird class, which is inherited by the parrot class. And we have the climb contract specified in the animal, and it is concretely implemented in the parrot. And we have the fly method, which is in the bird. And hence, since parrot is also a bird, we've just managed to remove that completely from here, thereby solving our issue. So, but in order to make sure we did get this right, I will always run the application and make sure we are still getting the same output as what we got initially. So now Glory has no problem in flying, even though it is now using a multi-level inheritance. So we can actually now go ahead and add any number of birds without having to worry about repeating the fly behavior across these birds. So all we have to do is, let's say if we wanted to add a peacock, we will just say public class peacock inherits bird. And as usual, since the climb is a little different, we'll have to go ahead and provide a separate implementation for them. But we have the contract ready in the animal. The contract is all animals do climb. How they do is depending on the specific species we are talking about. So our code right now is at a much more extensible and maintainable format. But what about the problem of repetition here, which we intended to solve? We still are repeating a lot of stuff, and we discussed that this will be not practical at all, as and when the categories of the animals increase and as and when the number of records we have in the application specific to these also increase. So we'll see that in a while. But before we go there, I would also like to bring in a concept like, what if I want the parrot to be able to sing as well? Now, this is not as straightforward as it looks. If you Now, where do we put this method here? So if you thought that we can put the sing method, let's say somewhere in the animal, that would be wrong. Not all animals can sing. In fact, animals cannot sing. It is only a few birds, like a parrot, which can sing. So I can't even put it here. I can't put the fly method here. I'm sorry, the sing method here, because not all birds can sing. So if you take something like an eagle, there's no way an eagle can sing. So what do we do with a behavior like this is the question. So if I can generalize this, if we have a specific behavior, or sorry, I'll put it this way, if we have a behavior which is exhibited only by a specific child in the hierarchy, we cannot generalize it, meaning I cannot put it in bird, I cannot put the sing in animal. So what do we do in this case? So basically we have a behavior which is exhibited only by a specific child. Or maybe, let's say if we consider something like a peacock, and we can assume that a peacock can also sing. So we just have a couple of birds which can sing and all other birds cannot. So how do we deal with this situation? So this is where interfaces come in handy, and we can discuss this in the next video.